Hello everyone, welcome to the separator museum. In the last issue, we discussed free test heads, with only one average air permeability tester. Someone might ask, if the instrument can provide three independent data points, measuring three at once and outputting three numbers, wouldn't that be efficient? Today, let's talk about this three-head free data air permeability tester. It appears to address the issue of information transparency, but another more fundamental problem remains. What exactly determines efficiency? Three data points do not equate to 3 times the efficiency. At first glance, with 3 test heads operating simultaneously and measuring 3 samples at once, it appears 3 times faster than a single-head instrument. But the real question is, how long does one test take? A three-head air permeability tester takes 1 minute from clamping to test completion, allowing a maximum of 180 samples per hour. In contrast, a high-efficiency single-head air permeability tester requires only a few seconds per test, and with clamping and switching included, its hourly testing capacity far exceeds that of the former. When a design is chosen by major global manufacturers, it must have profound engineering logic behind it. Currently, the mainstream membrane air permeability testers on the market, such as those from Jinan CK, Gurley in the US, and Japanese products, all feature a single-head design. These companies, with years of expertise in membrane testing, clearly understand that for materials like membranes which exhibit high air permeability and fast testing speeds, a single-head design is the optimal solution. So, where do these 3 testing head instruments come from? The genes of such instruments often originate from another field, food and pharmaceutical packaging material testing. Food and drug packaging materials have low breathability, and the testing process itself is slow, taking several hours or even dozens of hours to complete a single sample. In this field, increasing testing efficiency by using multiple test chambers is meaningful since the testing is slow. Parallel processing is necessary to compensate. However, problems arise when this design is directly transplanted into the diaphragm field. Diaphragms have excellent breathability and fast testing, eliminating the need to compensate for speed with multiple heads. On the contrary, the complex structure of multiple heads introduces new issues. How to ensure pressure consistency among the 3 heads? Is clamping convenient? Is maintenance complex? And others. Applying the testing logic of food and drug packaging to diaphragms is like putting marathon shoes on a sprinter, not unusable, but truly inappropriate. Beyond testing speed, the user experience is another efficiency factor often overlooked. 3 test heads operate simultaneously, meaning 3 samples must be clamped at once each time. If the clamping process itself is already cumbersome, the safe testing time is then consumed in clamping and adjustments. With the 3 heads positioned differently and offering varying perspectives, operators must frequently move and repeatedly confirm. By the end of the day, the result is not increased efficiency but accumulative fatigue. True efficiency lies in allowing the operator to focus on the sample itself, rather than struggling with the instrument. Let's go back to the original question, is 3 pieces of data enough for efficiency? The answer depends on your definition of efficiency. If efficiency merely means how many can be tested at once, then 3 heads are indeed more than 1. But if efficiency refers to how many valid and reliable data points can be obtained per unit time, then it depends on speed of a single test, convenience of clamp switching, the stability of the instrument under prolonged operation, the degree of traceability and reliability of data. When an instrument performs exceptionally well across all these dimensions, even with just a single test head, it is truly efficient. Conversely, if an instrument only focuses on increasing the number of heads while compromising testing speed, operational convenience, and data reliability, then the 3 heads merely result in a superficial more rather than a genuine faster. Enterprises that have been deeply engaged in the field of membrane testing for years have unanimously opted for a single-head design, which is not a coincidence but a profound understanding of the characteristics of membrane materials and testing requirements. For users, when choosing a breathability meter, it's worth asking a question, is this design meant to solve my problem, or just to make the parameter table look better? After all, instruments are meant to be used, not merely looked at. Thank you for watching this episode of separator Museum. See you next time.